Hello, everyone. My name is Patrick Grady. I'm the Assistant Product Manager or the TMS Presetter Department. Today, we are going to be talking about switching from negative to positive offsets and how an offline presetter can facilitate with that change. So we'll be discussing some traditional touch-off methods, as well as some of the pitfalls of using negative offsets and how using those traditional touch-off methods can be problematic. We'll also talk about how positive offsets can increase accuracy and productivity. We'll also be talking about additional benefits of using the presetters themselves, so not just measuring gauge lengths, but what else can the presetter bring to the table. We will also talk about how to actually make the change from negative to positive offsets. So, start off with talking about the traditional touch-off methods. Traditionally, people have put the tool in the spindle, jogged it down, and then they'll touch off on either the workpiece, the fixture, possibly even the table, or probably more commonly using something like a gauge block. As seen in the picture here, there's a 1, 2, 3 block. The operator would move that gauge block in and out while slowly jogging down that tool until it makes contact. And then they'd be looking at the Z-axis readout and the control to then get that height offset. So this was more common years ago, but still very common to this day. So the offsets gained from the traditional touch-off method are only going to be relative for that tool in that machine. So if you want to take that tool out of the spindle and take it to another machine center, you are not going to get the same results with that measurement. So you would have to then touch off again, which is of course time-consuming when that spindle could be running. If a fixture is moved or replaced for a new job, of course, if you're touching off on that fixture, you're going to have to retouch off that tool since that fixture has moved or changed completely. Of course, doing these traditional kind of touch-offs can have their own problems. For example, the paper method, where an operator machinist might grab a piece of notebook paper or a sticky note, as I see a lot of times, or my personal favorite, a cigarette rolling paper, and then kind of the same idea with the gauge block. They'll just slowly shimmy that paper underneath the tool, slowly jogging it down until that paper stops moving. Problem with this is that the thickness of that paper can vary by a matter of thousands. So once that paper stops moving, a lot of people will get in their minds of just look at that Z-axis readout and go, oh, there's my number. Some people will take that thickness into account, but oftentimes it's a guess. So you could be anywhere from 1 thou to 3, maybe 5 thou off, and what your actual tool offset is. So it's just kind of an inherently less precise way of measuring the tools. And then the biggest problem, in mine and many others' opinion, is that you're not making chips during this whole process. Really, you're losing money. That machine could be making parts, but instead you are setting up for that job, which of course could be done in an offline manner. A little bit more of an upgraded way to touch off the tools inside the machine would be with an in-machine tool setter. There's different versions of these. I'm sure a lot of people are familiar with the Renishaw touch probes. A lot of them are already mounted on the table of the machine. Some of them are ones that can be removed in and out. Either they're magnetic or just have a ground finish that'll sit flat on the table, fixture, or possibly workpiece that they might be touching off on. And those will have a predefined height. For example, the one in the picture would be something like 2 inches in height. And as soon as that tool makes contact, it's either going to have a touch sensor. So as soon as it moves in the slightest bit, that light's going to go off, or it'll make a beep, alerting the operator stop jogging that down, and then they can take that Z-axis reading off the control. Some of them also work by electrical conductivity, so that as soon as that tip of the tool makes contact, it'll register that, once again, alerting the operator to stop motion. So this is definitely a more reliable and versatile way of doing this. Once again, that given height of the setter is definitely better than the paper method, definitely better than using a business card to try and set your heights. However, machine is still not making chips during this time, so we're still wasting setup time, wasting money. Touch-up values, of course, still negative, so it's still relative to that machine. You can't take it to another machine and then run it with whatever that negative offset might be. So the downsides of using these negative offsets, once again, still only relative to that machine it's taken in. Negative values can just cause a possibility of increasing error. So it's just harder it can be harder for people to think about negative offsets. So for example, if you have a 6-inch tool, 5-inch tool, whatever it might be, once you touch that off, that readout is going to be something along the lines of a fairly large negative number. Basically, it's the stroke of the z-axis from open height down to whenever that tool makes contact with whatever gauge they're using. So if you have something like negative 23 inches and change, it's just that much more difficult to think about how you might make compensations or calculations when dealing with that. I know it might sound a little silly or punitive, but it really can have an impact. So what are the benefits of using presetting with positive values? So the offset is, of course, the true length of that tool from gauge line. For example, if it's a Cat 40, it's the diameter of the taper at 1 inch, and 1 3/4 inch would be gauge line, which is kind of a hard number to figure out. So if you have a presetter and we're measuring from positive values, everything is in relation to the spindle, not in relation to that z-axis stroke. It just makes for a little bit more accurate, more repeatable measurements. Tools can be used interchangeably between different machines. So like I was talking about before, if you're getting that negative offset, you can't then take that tool and move it to a different machine. With positive offsets, once again, everything's relative to that spindle. You can move tools around as you please. In fact, we've got a number of companies that are doing this where once they get that measurement for the tool, in the case of measuring it on a presetter, they're then putting a label on it or even putting a barcode on it, and it has that gauge length information recorded on there. So then they're just keeping that in carts, and whenever they need that tool, they can then grab that tool, look at that number, and know that it's going to run well and run properly. And so they can enter that number into the control, and off they go. They're not spending that time touching off, and not even spending the time going to the presetter at that point. It's already been done. They know it's good, and they can trust it. Also, moving or changing fixtures does not force you to remeasure those tools. So that's just an added benefit. If you change that out, still relative to the spindle, no need to retouch off. And positive values are just easier to think about and do calculations with. Again, I know some people might think that's silly, but anything you can help to reduce error is always going to be a benefit. So some of the additional benefits of using a presetter over just a touch probe or even a gauge block for negative value touch off is that the presetter can do a full spectrum of additional inspections that you just can't do inside the machine. I hear it a lot. Well, I've got a Renishaw touch probe that's mounted in my Haas, and not only can it measure my gauge length, but it can also measure the diameter. Now, while that's true, you could still be presetting it offline, and you're not spending that time touching off, let's say, 20 different tools. Granted, we're talking a matter of minutes, but that's still minutes saved. In many cases, once you preset offline, you can completely eliminate the need to do test cuts. We've got a lot of places that will either take a piece of scrap or a blank, whatever they're working with, run test cuts to make sure all the tools are set properly. Well, if you have a presetter, for the most part, it's going to eliminate that need altogether. Everything can be set. You can verify all the tool geometries before, or not completely eliminating the need to run those test cuts. I don't know if anyone's ever set up a boring bar inside of a machine, but it can be a bit of an uncomfortable thing to do, whereas doing it on presetter is a lot easier. So instead of putting that dial indicator in there and dialing that initial bore diameter where you need to be, the presetter can lock that boring bar in, and you get an instant readout. That camera is picking up the edge of that cutter, and you can move that in and out and get that exact bore diameter that you're looking for. So presetters can measure a number of additional extra features. One that I run into a lot, tool stick outs. Really helpful in many situations, as well as extremely critical for those 5-axis applications. Measuring radii, angles, other tool geometry. As far as measuring corner radiuses, it's extremely helpful. We can measure the overall radius of a ball nose end mill or corner rounder. We can do a number of different radial tangent points. These are things that touch probes you're certainly not going to be able to do, or in machine touch probes you're certainly not going to be able to measure a lot of these features. Verifying form tool geometry. We've got a lot of places out there using form cutters where it's not the tip of that tool that's set for the Z gauge length. It's some other form feature further into that tool. So it might be a certain face or certain angle, like a shoulder point of that form tool. And it might either be extremely difficult to measure on a touch block or just completely impossible. So really that's where presetter can come into play and help out a lot. Theoretical points as well are another great use for a presetter. A lot of programmers love the theoretical sharp point measurement. So you can take a drill or a chamfer even and measure the two angles, and wherever they intersect, that'll then be your Z gauge length to work with. A lot of places I go to in the field really, really love this. So another thing is runout. Now, if you do have a touch probe that can measure diameter, and like I said, I hear this a lot. Well, I can measure height and diameter. What do I need a presetter for? But you can't really measure the runout on a touch probe, at least not easily. Whereas on the presetter, it takes all of about 5 seconds to measure the runout. And then you can, if you do find runout, you can figure out, well, what's causing this? Is it the collet? Is it the holder itself? Maybe the inserts just aren't set in the pockets properly. And the presetter is going to allow you to fix these issues so that you don't see it when the tool is actually running. So this is going to help reduce scrap. It's going to help increase part quality and increase tool life. And it always shocks me how many places I go to, and I'll set up a presetter and I'll run their tools through it, and they look at it and they say, oh, that has 2, 3, 4, 5 thousandths run out or more. And they start questioning the presetter, and you have to go, no, this is actually coming from the tools. And we can put a gauge bar in the presetter and prove that out. And it really does surprise a lot of people how much runout some of their tools have, and they really don't even know it. Another benefit we can see from presetter is a visual inspection of the cutting edge itself. So most presetters are set to a 45x magnification. We also have a front inspection line, so that'll allow you to view the cutting edge itself instead of just a black and white shadow. And we can detect things like worn inserts, chipping, fracturing, built-up edges, a variety of other issues. And in fact, I went to an aerospace company that was all they would cut is Inconel, and they had I don't even know how many boring bars, several dozen that they were using. And when they decided to upgrade from a dial indicator presetter, which is really exactly what it sounds like, presetter with a dial indicator, you touch it off on the tool, you zero out the indicator, and then that reads out your height and diameter. Well, that's how they've been doing it for years. And when I went there, they said, you know, we have been having problems with some of our finishes after we run these bars. And so once we got the Speroni Magis presetter up, which is a camera-based presetter, we were able to look at every single one of their boring bar inserts. The corner radius had been ground completely flat from running them. They just hadn't been changing out those inserts as much as they should have been, and they really had no idea. And so it wasn't until after they got an optical presetter that they were able to check this and then change out those inserts when it came time. So they really experienced a large benefit from that kind of presetter. Another thing that presetters are capable of doing is tool data management. So we can set up a part or job specific setup list. So for example, the operator can go to the presetter, type in the part number for the job they're about to run, and then get all the list of tools that they need for that job. And of course, the machines can be running at this time, so they're reducing that setup time by doing this while they're running their current job, setting up for the next. And so once they have all those tools on the list, they can go through one by one, and the presetter is going to tell them, you know, setup instructions, what, like I said, what tools they're going to need, maybe specifics like what kind of inserts they might need to use, how much stick out that tool might need, even special notes that someone can leave for other operators. This is just going to really help reduce error for tools going out to the machines. To add to this, a CNC presetter can further decrease the amount of time it takes to then set these up. So for example, for the fully automatic presetter, the operator can set that tool in the spindle, call that tool or job up, tell it to run a full automatic measurement sweep, and then they can go to a setup bench, grab another tool, and start assembling that tool while it's running, measuring the tool that they just put in the presetter. So if you really want to increase efficiency, this is a great way to do it. And once those measurements are taken, they can be stored in a list, which can then be post-processed. And by post-process, I mean sending those height measurements out directly to the machine center control. So typically we'll be doing this using G-code, like a G10 line, for example, but we can work with other languages. Basically, it's a fully editable post-processor, so whatever language we need to communicate with, we can do that. And it's not just for sending gauge lengths. We can also send wear comps for diameters, even heights as well, potentially, although diameters is more common. But really, whatever is going to work for the end user, it can be set up to work with how they want. So direct downloading really helps eliminate the fat finger problem. You know, we all see that a lot. You think what you saw was a 1, it turns out to be a 7. If you're sending that over directly from the presetter, it really eliminates accidentally hitting that wrong key and possibly either causing a crash or scrapping that part. We can use, like I said before, we can use multiple formats. So you can use a single presetter to support either an entire shop or cell, just depending on how many machines they're working with and how large the place is. So switching from negative to positive offsets, how might you actually go about that? Well, luckily, most modern controls are already set to accept positive tool lengths. You know, anything that's going to be any control that's fairly recent, you'll be able to go in and find a parameter change, and it'll just do that map for you. When doing this, it's always recommended to use a probe or master gauge to then calibrate all the machines to the same height. So either you can use that value that's stamped on that gauge or master cylinder, or if you have something like you know, a touch probe in a cat holder, you could then preset that on the offline presetter, get that gauge value, and then use that as the master. And then everything is relative to the presetter and not relative to each machine separately. You can also potentially create a macro or subroutine that can figure out whatever that stroke is from the spindle down to either the table or work fixture, and have some kind of macro that will intake a positive gauge length value and then spit that out to the control properly. So should you make the switch to positive offset? Well, do you want to increase spindle uptime while reducing setup times? Do you want to standardize tool length offset shop wide? Do you want to make it easier for operators and machinists to perform fetter counts? Do you want to increase first part precision and avoid scrap? If you answered yes to any of the above, it's always worth considering an offline tool presetter. All right, thank you very much.
Does anybody have any questions? Okay. I do. Can I transfer offsets from the, I'm sorry.
No, sorry, go ahead.
Okay. Can I transfer offsets from the presetter to the machine control via my DNC?
Yeah, absolutely. Really, you can do it whichever way you prefer. DNC tends to be the most common, but a lot of places will load that G-code program or whatever program they might be using to transfer the offset onto, let's say, a USB stick. But yeah, DNC does tend to be the most popular method.
Will it only transfer positive offsets?
No, you can work with negative offsets. It's not recommended. What can happen is you do have to have multiple machine-specific offsets in the presetter. So let's say you have 25 different machines on the shop floor. Well, then you have to have 25 different comps, which means the operator could potentially select the wrong one, and you could have a crash. But the presetter can accommodate both positive and negative values.
Okay. If my machine is equipped with a laser instead of a touch probe, why would I need a presetter?
So lasers can potentially measure things like run out. They will get your gauge lengths and diameters. However, all those additional form factor checks that I talked about, a lot of times they're just not capable of doing it, or they're not as accurate in doing it as the presetter. And then once again, the machine still isn't running while the laser is working. However, what I tell a lot of people, the laser is great for breakage detection. So in my opinion, the lasers go very well in addition to a presetter.
Okay. How much time can be saved by using a presetter instead of a touching off in a machine?
That's going to vary. Anywhere from hours to minutes. It just depends on how long their current setup times are. I mean, the biggest thing to remember is that that machine can be running a job while that operator has downtime. Then they can take all their tools and set them up on the presetter. So, I mean, sure, we've seen as little as it saves maybe 10 minutes, a few minutes here and there, to it saves multiple hours. It really just depends on shop to shop and how much time they're currently spending during setup.
Okay. If I don't have a calibration master, is it possible to calibrate all machines to the same standard?
Yes. When I go to places and they don't have either probe or master, my recommendation is to take a drill and measure it in the presetter, get that gauge length, and then use that as a master. This way the presetter is kind of becomes God. It's the master that's used for all the machines in the shop. So yes.
Okay. How long does it take to measure a tool length offset on a presetter versus touching off in a machine?
It depends on how many tools, but once again, it's going to vary from company to company. But really it's the same thing, anywhere from minutes to hours, just depending on exactly what they have to set up.
All right. Does anybody have any other questions? I don't think so. Thank you, Patrick.
You're very welcome. Thank you, everyone, for listening.
Have a great day.
You too.
Bye-bye.
Bye.